We'll discuss today about UDP, user defined primitives. Okay, the logic gates used in HDL descriptions with keywords and or XR, XNOR, not are defined by the system and are referred to as system primitives or gate primitives, because those primitives, those keywords, those gates are already predefined by the what software. So that's why they are called the system primitives. The logic gates used in HDL, hardware description language, descriptions with keywords. Which keywords we will use? And, or, not, XR, XNOR, NAND, NOR. All these are system primitives. The user can create additional primitives by defining them in tabular form. So like system primitives, user also able to create some primitives. So generally, user primitives are created in tabular form. Okay, so these type of circuits are referred to as user defined primitives. Two types of UDPs. One is combinational, one more is sequential. UDP do not use the keyword module. It doesn't have any module. So like your design program will always start with the module, ends with the end module. So like that, it could not use the module keyword. Instead, they are declared with the keyword primitive. You should write primitive. Instead of the module, you should write the primitive. After that, as before, module identifier. Here primitive identifier is required. Module name, like primitive name. There can be only one output and it must be listed first in the port list and declared with an output keyword. If you see all system primitives, not, and, or, XR, XNOR, NAND, NOR, irrespective of the number of inputs, always the output is single. Like here also, in UDP also, only one output. Of course, as I said before, user-defined primitive is a small program. But this program should not be start with the module keyword. It should be start with the primitive. It has a single output. Output must be declared as output. Okay. So of course, you can have a many number of inputs. They can be declared as inputs, as in the program. Okay. The truth table is enclosed within the keywords table and any table. For the user defined primitive, table is required. Generally, it is a truth table of the corresponding circuit. The table must be inserted between the table and the table. The values of the inputs are listed with a colon The output is always the last entity in your row followed by the semicolon. So finally, it should be terminated with the completed with the AND primitive. See this example. This is the program. This is the UDP, user defined primitive, a program. This is the multiplexer I'm talking. Multiplexer. Two to one max. What is the truth table? See. So this is the output, max is output. Now we can say this is the truth table. Primitive. Started the pattern. Now I what is the name? Multiplex research. Write the course. Output is inputs are select plus semicolon. Output comma now write the table. So this must be there. Finally, and table is there. Table. Number two, the last one is and table. So you should insert the table here in between table and end table. What is that? See, this is the order. Suddenly, picture. 2 into 1 max. Select it 0. A is 1. Don't know about B. Then, as this one, what will come? Select it 0. Means A is so not selection was on 0 so here is which means question mark means what either 0 or 1. Question mark means here question marks any three values. Any of the three values. 0, 1, and what will come? When I select 0, what happened? Automatically A will come. What is the A value? So this is column is separate the inputs and outputs. Each can be separated with the same. What is the order I said in the table? Inputs, column, output, semicolon. What is the order? Select is one. So A is question mark. B is one. Answer is one. So selected is one means this will select. What is the B value? One. So one. Now two more cases. Suppose this is don't care. Both are zeros. 1 0. 1. Of this table, what is this use of this module? Ability. If you write and kept in the different like this, whenever you want 2 to 1 multiplication, you can directly count it with the okay. So that is the understand. UDP is a user-defined program or primitive. So for this, you can imagine it is a small program. You should write it and keep in the library for the further use. No need to design always this multiplexer because already it is along with the system primitives. It is also in the library. You can use. What I told you, how to write it. Any primitive, use UDP primitive. Okay, it has only one input, any number of inputs. One output, any number of inputs. Okay. See, this is a small example for the what is it on multiplexer defined as UDP. No doubt. Truth table ఇస్తాం. కావాలంటే చేసుకుంటా లేదంటే లేదు. ఇది చేసుకుంటే ఎప్పటికీ అది ఉంటుంది. నువ్వు ఎలాగైతే అండర్గేట్ కావాల్సిన వేయండి అని రాస్తున్నావు, మల్టీప్లెక్స్ కావాల్సిన మల్టీప్లెక్స్ అని రాస్తే వచ్చేస్తుంది. వస్తుంది. Yeah. A combinational UDP uses the values of its inputs to determine the next value of its output. The first line. So inputs are there. Colon. What is the output for that? That is the way of writing. This is the combination. Mux is a combination circuit. So similarly, you can use for this what? Sequential also. A sequential UDP uses the value of its inputs and the current values of its outputs to determine the next value of its outputs. Q, sorry, S or Qn plus 1. Suppose S or present state to next state, present output to next output. Sequential UDPs provide a way to model sequence circuits such as flip-flops and latches. Sequential UDP can model both level sensitive and edge sensitive behavior. Each UDP has exactly one output, which can be in one of the three states, 0, 1, X. So in the earlier truth table, you have all the combinations. Z is not supported. The Z values passed to UDP shall be treated as same as X values. This is the sequential latch. Okay, level sensitive latch. Latch. Say or I didn't say. So bracket open. Lock because of sequential. And delatch. Got it? What is the output? Is always out. So what is the output here? Q. Okay. So as sequence circuits we know, outputs are always resistant. So this Q. So always resistant. Inputs are data, comma, now. Now write the table. So order is clock. So data, Q, Q plus. Is the order. How many outputs are there here? In the table, two. Present state to next state. Suppose clock is 0, data is 1. Okay. And present output is, I don't know. Then output is present. Next output is 1. Because data is 1. When clock is 0, data is 0. So present state is 1. The output is 0. If clock is 1, data is question mark. Present state is question mark. Output is what? No change. No change. Whatever the front table and primitive. So what is this clock? See, positive clock and negative clock. This is operative. Huh? Positive. 0 to 1. 0 to 1. This is 0 to 1 to 0. Language. 1 to 0. So because 0. So 0 clock. Whatever the data, that is the output. At last, Friday conduct చేస్తుందండి ఎగ్జామ్ ఫ్రైడే కండక్ట్ చేసిన ఎగ్జామ్ నేను ఫ్రైడే సింపుల్గా ఉన్నది రెండు పెట్టుకోండి డేటా ఫ్లో ఈజీ కదండి ఓకే నెక్స్ట్ వన్ సి హెడ్స్ అప్పుడు మర్చిపోతారు ఇవన్నీ హెడ్ సెన్సిటివ్ సీక్వెన్షియల్ యూడిపి హెడ్ సెన్సిటివ్ See, here is a edge tick grid, edge sensitive. Earlier is a level sensitive. See, because of that one clock, see in the bracket I wrote 0, 1, from 0 to 1. Changing from 0 to 1. Positive, edge sensitive. Second case also 0 to 1. Okay, remaining two are the 0 is 0 to don't care. Okay, first case if you take first case if you take, if data is 0, then output is 0, next state is 0, irrespective of the present state. If data is 1, output is 1. Here, output is, data is 1, so output is 1. This is treating as a 1. This is a no change case, state. No change. These two are the no change states. In earlier, what he said, clock is 1 and data is question, then no change. Here, the clock, I don't know. So that no change. Ignore negative edge of the clock. That is the negative edge అంటే 1 to 0 రాయలేదు. So because for that no changes. Okay. Same as it is. So I think all are the same. Out data ఏదైతే ఉందో present state ఏమైతే ఉందో నెక్స్ట్ స్టేట్ అదే వస్తుంది. Mm. Mm. ఎలాగలగా ఎక్కడమ్మా ఇగ్నోర్ స్టేట్సా అదే ఇగ్నోర్ చేసి మనం కదా అసలు ఇగ్నోర్ కామెంట్ పెట్టాం కదా ఇగ్నోర్ చేసి మనం ఏదైనా అదే suppose this is my UDP. This is my UDP. What is the name of this UDP? CRCTP. CRCTP. So main terms కి 1 వస్తుంది ఓకేనా ఏ మెయిన్ టర్మ్స్ 0 2 4 6 7 కి 1 వస్తుంది ఫంక్షన్ ఓకే సో I want to use this primitive in my program like this. You can use module. So declare underscore CRCTP is XYZ wire W. Then here is this is the statement which is calling this program CRCTP. Okay. The way you are instantiating the lower level modules and the top level modules, the same way you can use here. అదవుతుందా okay, do some exercise on that. Okay.